about simulating simple events. When we repeat a process inside of an experiment, it's called a replication. But when we take our theoretical probability and create an experimental probability, we do that through what's known as a simulation. So we know that when we flip a coin, it'll come up heads or tails. It's 50-50, it's 1 out of 2. That's what's known as a theoretical probability. But by doing replication throughout a simulation, repeating a process, we can make our theoretical probability of 1 out of 2 or 50% into an experimental probability. So that's what we're going to do. One of your questions in your assignment today talks about doing this 40 times. I'm going to do it 20 times in this video, and we're going to see if our theoretical probability of 50%, 1 out of 2, holds up for an experimental probability. So I'm going to flip this coin and we're going to see what happens. Here we go. So as you see, when we simulated this simple event, well, the theoretical probability was that it would be 50-50, 10 heads, 10 tails. We actually ended up with something that was different. It's close, but it's not that same 50-50. We ended up with 9 out of 20 and 11 out of 20. So a little over and a little under and a little over. That's because when we continue to repeat a process, each of those individual flips, that flip was a 50-50 chance. But over time, we did what was called a compound event. The actual likelihood of ending up with 50% heads and 50% tails was a lot less than 1 over 2. So next we're going to talk about compound events. So compound events deal with probabilities when we have more than one factors in play. So we had originally talked about flipping a coin. Yes, the probability of flipping one coin is 50-50, that would be heads or tails. When we're flipping that coin multiple times and looking for multiple results, that simple event now becomes a compound probability. The original flip, it's 50-50 that it'll wind up heads or tails. But then so is that second one, so is that third one. So I'm looking for a big string of answers. It's now compound. It's not just one event, otherwise known as a simple event. So what's the probability that if I were to flip a coin twice, that I would end up with double heads? Well, I know when I flip one coin, I can end up with heads or tails. Same with the second coin. So this is when we make an array. So what we need to do here is write down all of our different possibilities. If I were to flip the coin, what are my different likelihoods? I could end up with head heads, head tails, tails head, or tails tails. And there are 4 different outcomes. Now the favorable outcome, if you remember what I said, I wanted double heads. So the likelihood of me getting double heads would be 1 out of 4, as it is only one box. This is what's known as a compound event. So next we're going to try this using a bit different of a problem. So let's say I'm playing a game of darts and these are the possible point totals on the dartboard. I can get a 3, 6, or 9 and I'm throwing 2 darts. Whatever the 2 point totals that I land on, the sum is my answer. So I need to figure out what are my possible point total values, and I do that by adding both numbers from my column. So as you see, there are 9 different blocks, so there are 9 different possible outcomes. When we're talking about unique outcomes, there are 1, 2, 3, 4, 5 different unique outcomes, being 6, 9, 12, 15, and 18. Remember, this was out of 9 possible answers. So I'm going to write down what my probability of getting each number is right now. So as I said, there are 9 possible answers. Each one has a different probability of me getting it. The least likely numbers that I would get are 6 and 18, because they only have a 1 out of 9 possibility of me getting that. The most likely number would be 12. So the most likely answer that I would get, or the highest total I would get each time I'm throwing that dart, is 12. We're going to do one more problem this time talking about die. So my question is, what is the probability that if I were to roll 2 dice, that both die will have an odd number? Now I could do this with the array and I could actually try this all out, but as soon as I get past 3 or 4, it gets to be a little tedious to keep filling in those boxes. So I'm going to show you a little bit of a shortcut that we can do this, and it involves your favorite thing, fractions. So I know that on each die, there are 6 sides. So there are 6 possible numbers that I could roll on each die. So the likelihood that I would get an odd number, a 1, 3, or 5 on the first die would be 3 out of 6. The likelihood that I'd get an odd number on the second die would also be 3 out of 6. What I need to do here is multiply straight across. And I get 3 times 3, which is 9, and 6 times 6, which is 36. I can simplify this fraction by dividing both the top and the bottom by 9, and I end up with 1/4. So if you remember our fractions correlating to decimals, correlating to percentages, a 1/4 is a 25% possibility. So it is a 25% chance that if I were to roll 2 die, that I would end up with an odd number on both of them. I hope this helps. Remember to do your math yet, and we'll be meeting in Google Meets on Thursday at 9:45, and I hope to see you there. Bye.